Hello everyone. Just doing a quick sound check, making sure everything's a-okay. It's lovely to see you all. I know it's week 10, and I know we're pretty much wrapped up now. But nonetheless, this will be our last lecture together for the term. We naturally don't have a lot of people here today by virtue of it being the last lecture, which is fine. There's no issues with that at all. But we are going to have a little bit of fun, which is good. Let me just check one last thing before we get started. All right, hello. So, look, welcome to the bonus lecture on HTML, CSS, JavaScript, or sometimes we refer to it as the web bonus lecture. There's kind of a two-pronged purpose to this lecture. Firstly, one of them is that we give you this front end in the course, and front ends have become a huge part of software engineering in general, because so much of what we do with software nowadays is building user interfaces. In a way, if anything, that kind of might be probably for the first time I've ever seen it, maybe a slight shift away from that. I'd say like the last 15 years has really just been defined by the building of interfaces, like just in its entirety, like pretty much, the app revolution, the smartphone revolution, the massive increases to bandwidth we've had on the internet from 2005 through to 2015. It's just been an era of making interfaces on the internet. I did the deployment lecture where we talked about how the internet has changed. Front ends have been scooped up in front of that. When I said that, maybe this is the first time I've seen it not keep growing, I'd say like a lot of what is happening with AI recently is kind of the first time that I've probably seen a significant redirection of energy away from like we need to build more and more app and more features to like we need to build much, I guess, smarter things. Like there's definitely a bit of an information age that's starting to reappear now in terms of focus. But regardless of that, front ends interfaces are still massive, absolutely massive and dominant on top of everything else. So pretty much what we're going to do is I'm just going to demo you some really basic front-endy things. And the other reason for this, the second part, is because I run a front-end course at UNSW called COMP1530. And COMP1530 is purely a course on web front-end technologies. It's not about user interface design. It's about how do we use programming to build cool interfaces. Now, in terms of that, what I've got here is I literally have a file on my computer. You can go and make this file if you'd like to. It's called index.html. Now, you might be familiar with HTML, or you've seen it around, or you've seen a .html file if you've saved a web page. But HTML is basically the core language of the web. If I write a piece of text here, this is my website. What I can do is I can take that file and I can go and open it up in my web browser here. Now, what you'll notice is that this isn't some fancy web servery anything. I've literally gone and taken a text file on my computer. I've dragged it and I've dropped it in the browser, just like I'm dropping a PDF in the browser or something like that. It's really the same as like when you save a website and it downloads to a .html file and you go and like double click on that file and it opens it up in a web browser like this. Because you can see it's not loading it from the internet, it's loading it from my computer, in this case, the Windows subsystem for Linux. So I've got this page here. This is my website. So all that's really happening in this sense is that the web browser is treating this file nearly like a text file. However, HTML is more than just text. It has a whole bunch of things called tags. And one of the most basic tags you'll see is a bold tag. When I put that in, you'll notice that my text on the website changes from normal looking to bold looking. And this is the interesting thing though. The web browser, this is the code that it took from me. And this is the code that it appeared on the page. So the right way to imagine a web browser is to picture it as basically a compiler for your HTML and various other languages to run on the web browser. And instead of converting it to machine code, this compiler's job is to produce a web page like this, to render one, to create something visual. If I would like my text to be italic, then I can go and do this. And now I have a bold italic piece of text on the website. Now, the whole way that HTML is structured is relatively simple. You have a bunch of tags that have to have an opening and a closing, like this. And they are opened simply by putting the tag name in between the two side brackets, and they are closed by doing a similar thing except putting a slash there. So that's where you kind of get the open and close aspect from. Most tags have these things called attributes. Attributes are things that exist after the tag name but before the square brackets. And they might be something like size, and then the attribute has a value, which might be, say, 16. Now, this particular attribute value pair doesn't mean anything. However, I can show you one that does. If I just go to google.com and I go here and I right click and I get this. This is the URL of the Google logo for Google UK. I'm not sure why it's in the UK. But what I can do here is if I just go and say image, so this is one, actually, let me give you a better example first. Let's imagine that I want to say, let's go to Google. There's another tag called A, which is anchor. Now, anchor is essentially a way of saying, I want to link to something. And one of the attributes that you can give Anchor is you can give it a hyperlink reference. Hyperlink just refers to URL. We'd kind of refer to that colloquially as URL. And let's just imagine that I want to send someone to google.co.uk like this. Now I have my open tag, my close tag, and I put stuff inside of it just like everything else. And now this will create a web page where I have a bold, italic, hyperlink like this. And when I click on it, it takes me to Google UK. So this is an example of having an attribute and value associated with that tag. I can add more attribute values if I want. One popular attribute value pair you'll see is target equals underscore blank. What that'll do is that'll basically open it in a new tab for me. So that's how I can force links to open up in a new tab. More specifically, it's not that it opens in a new tab, it's that it tells the browser to open this in a new thing, and the browser has commands and settings that are used to determine whether it's a new tab or window, because you can actually go and change that behavior in your web browser if you want. Because originally, back before tabs were kind of invented in the early 2000s, it just used to open things in a new window. Now there's a special type of tag called a void tag, and a void tag is one where there is no opening and closing, because there's nothing to contain within it. It's typically tags that are never going to have text inside of it or any other kind of content. So this one here is a horizontal rule, which is basically a new line on the page. With void tags, they don't have opens and closes. They don't look like this, right? They literally just are a single thing, and they are a little bit odd because you basically say the tag and then the close like that. That's just how they work. Another popular void tag is an image. So you can add an image to your page, and one thing you do with your image is you include an attribute called source, which is the source of the image, where you can put in a URL. So I'm going to put in Google's URL, and now I have a little web page that I made here with some text that says, let's go to Google, and then I have Google, like that. A lot of web pages are wrapped in some big broad tags, the most common one just being the body tag. And that doesn't really do much for us at the moment, but there's a lot of structure to normal HTML pages that I'm not going to go into. I'll show you briefly. But most HTML pages generally follow this basic structure where they've got a head and they've got a body. And they have a bunch of stuff in the head, but one of the obvious ones is the title. Have a look at the index.html here. When I refresh my page after making that change, it says go to Google. So that's how you can control that. The purpose of the head is to do things like load in external files that are necessary for the rendering of the page initially. It's to do things like to set the little favorite icon, that little icon you'll see there with Google. There's lots and lots of little stuff that happens, but the actual code that renders what you're displaying happens inside the body. That's what actually appears on the page. So that's HTML in a nutshell. Now, the cool thing about explaining HTML to you is how would you put it? Like, it's very basic. HTML is just that, but larger. There's a lot of tags. If I go look up HTML tags, you'll see that there's a long list of HTML tags. Even more, I guess, on the next page. Lots and lots and lots and lots. But they all follow the same principles. They're tags with attributes, values, and you can put things inside of it. That's the beauty of it. We've got video tags where you can basically include a video on your page, audio tags where you can play music. And some of these tags are newer, some of these tags are older. How it works is that there's international bodies out there. They come together now and again and they say, what would be really powerful for web browsers to be able to do in terms of HTML? And then they set some rules, and then products run by companies like products like Chrome and Firefox and Safari, they implement these standards so that people can use them. And that's why web browsers essentially behave like compilers, because what happens is compilers, there's a language rule, compilers now have to support it so that when someone writes code of that language, it actually does the thing with it. And web browsers are no different. But that's all HTML. That's all HTML. The next thing we're going to kind of touch on is CSS. Now, to understand CSS, and CSS stands for Cascading Style Sheets, CSS was introduced a couple of years after HTML as an attempt to make web pages look a lot prettier. The way that I usually describe to the COMP1531 students is that the old web before CSS mostly just looked like Wikipedia. That was it. It just kind of was like text, boxes, images, like really, really basic stuff. You could have built a page like this 25 years ago, maybe 30 years ago, maybe not 30. Anyway, close enough. And it would have been perfectly fine. So pretty powerful. Like it's powerful in the sense that it's very universal. Everyone understands it. It doesn't require a lot of processing demands. It's pretty funny that we're kind of, talking about that when we got a random article of a graphics controller. But it's very, very simple. So CSS was introduced as a way to prettify pages. Now, the way you use CSS is you basically use it within HTML. So there's actually a tag called style. And inside that style tag, I can go and write CSS. So in here's all CSS. And CSS is even simpler than HTML. How it works structurally is that there's a thing called a selector, like this. A selector tells you what part of HTML you want to change the look of. And then all you do is inside the brackets next to the selector, you describe what you want it to do differently. So for instance, let's say I look at this page and I think, you know what, it's a bit bland. Let's go and create a black background instead. That CSS at, not at scale is it's basically you say, here's my selector. Here's the thing I want to apply some looks to. And then inside the brackets, you give it a list of looks. Now, like HTML, CSS has a bunch of properties, right? So HTML has tags, lots of tags, and each tag has its own unique set of attributes. CSS is even simpler because there are just CSS properties, and they're all listed out on this page. I believe this, if not everything, it would be pretty close to everything. And you can do tons of stuff with that. So for instance, let's say I look at this page and I think, you know what, I'd really like my text to be white. So color is the color of text. That'll make the text white. That's actually a problem because it's a link. I'll come back to that. Maybe I'll make it gray. Probably look worse. Yellow. Let's make it bright yellow. Really dramatic. But now what I also want to do is I want to say, you know what, I don't like that Times New Roman font. Let's use Arial. So now the text is slightly different. And then I think, you know what, the text on this page is a little bit weird. Let's make it twice the normal size for people. Okay, cool. So now that seems to work fine. Selectors can be done a bunch of different ways. You've seen in this case that the way I've done the selector is I basically described the tag and I want it to apply to all the tags. I can do that as well for something like an image. If I want every image to have a 1 pixel border, I think I usually have to, border. I don't normally write it like that. Black. I want to have a 1 pixel solid black border. Now it's got that, and then I think, oh my God, that border is really close to the image. So I want to create some space between the image and the border of 5 pixels. I think, oh, that looks a bit nice. So maybe I'll give it a bit more space, 10 pixels. And then I think those corners look really harsh. So maybe I'll give the border of that box a radius of 5 pixels so that maybe we'll go 10 again. So that it kind of edges it off a little bit. And I think, okay, that looks nice. And then I think, oh, it looks kind of funny because the top, the Google kind of seems closer to the top than the bottom. So I maybe will put in, I'll override the padding and say, yeah, the overall padding's 10 pixels on every side, but let's actually make the top padding 15 pixels just to give it a bit more extra space. And then you think, okay, well, that seems to be good now. We could add some more properties like box shadow. With box shadow, typically what you do is you tell it where you want the shadow to be as the first two, which is I want it to be 5 pixels to the right, 5 pixels down. Then you tell it how much you want the shadow to be spread over, maybe another 5 pixels, or maybe they make that 10 pixels. And then I give it a color, which in this case, I'll give it black as well. So now I've got the shadow here and I think, oh, that black's pretty harsh. Maybe I'll make it red. That would be awful, but gray. And then I think, I kind of want more control over my color. How do I kind of say I want like a really light black? Well, I can actually, instead of describing colors, I can give them RGB values. So I could say, 000 for black. Or if I want full blue, then I get something like this, right? So I can play around with RGBs. I can also do RGBAs where the last one is basically how transparent it is. So if I do 0.5, it's half transparent over the page. And it's interesting because that's kind of different to like being gray is different to being black half transparent because now it's a little bit see-through. It's like having a black film, like a really thin black film versus a gray solid piece of paper. So there's a lot to kind of unpack there. The other ways you can do selectors are that you can describe things by particular IDs or classes. So for instance, let's imagine that I have some text on the page here and I say, this is a paragraph because that's what P means. And I've got 4 paragraphs on my page like this. However, I kind of want the first paragraph to be a different color. So I'm going to give it an ID, and the ID is going to be called like first. So now what I can say is I can actually do hash here and say hash first. And what that means is go apply these styles to any HTML attribute that has ID first. And this one might be, you know, color gray or something like that. Cool. Now, what if I want to apply it to many styles, but not all style, is I can add a class to my HTML tags like this. Now, classes are used when you want to apply styles to many things, and IDs are used when you want to apply styles to one thing. And I might make this one, for instance, a smaller font or something like that. Oh, so what's happening here? Well, now I probably got two conflicting things because I have this font size of 1 EM here and this font size of 2 EM here. Let me see if I can fix that quickly. Just making sure I did it right. There's some kind of like order of operations things going on here. Maybe I have to do half. Is that how it works? I guess so. It's probably like math. You probably have to like, if you double it, you probably have to halve it. I don't normally do a lot with font sizing these days, but there you go. So there's my little page, right? So pretty cool. I've gone and made it kind of colorful and interesting. Now, that's kind of it. I'm going to pause there quickly because we're powering through this because there's not a lot of questions, and we've got 13 people here now. Does anyone have any questions they want to ask about this so far? Okay, I'll keep moving on then. So the next thing we're going to learn about is JavaScript. So like firstly, the cool thing about the HTML and CSS is I really have taught you like a lot of it already. In the sense that like you might not be comfortable with it, but if you went and just did a lot of HTML and CSS, you would not be surprised by much. You'd learn a lot more about tags and properties and selectors and attributes, but it's all the same fundamental stuff. Where things get slightly trickier is JavaScript. So we included the CSS on our page here up in the head. We include the JavaScript at the end of the body. JavaScript appears as a script here. Now, the cool thing about the crappy thing about JavaScript is it's way harder than HTML and CSS. HTML and CSS combined are like way easier than JavaScript because JavaScript's a programming language, you know? HTML and CSS are kind of these markup languages where there's just not a lot to them. The good news, though, is that you in this course have learned a lot of JavaScript already. Now, one of the tricky things, though, and I'll try and explain this, is that in JavaScript, what happens is you have the JavaScript language like this, and then what people go and do is they go and create runtime environments. One of them is Node.js, and then there's another runtime environment, which is the web browser. And what this means is, and this is where things get really confusing, with JavaScript, you kind of know JavaScript, but you also kind of don't, because when you use Node.js, which a lot of you have used before this point, Node.js consists of a bunch of fundamental JavaScripty things, and then also some Node.js specific things. It's the same and opposite for the web browser in the sense that the web browser has the same core JavaScriptness, but it has its own runtime environments. Now, what I mean by that is there's a bunch of stuff you would have done in Node.js, like import path from path, or npm installs, or file system.writesync, or whatever else. Like a lot of this stuff is specific to Node.js. It is not part of JavaScript core, you know? However, what is part of JavaScript core is saying things like this. These loops. This is all part of JavaScript core, functions, right? Things like that, array.map, all part of JavaScript core. So the web browser, there's a lot of knowledge you can reuse, but then there's a lot of knowledge that's very different. as an example, here I can write const A equals 5, const B equals 6, 7, const C equals A plus B, console.log, sum is C. I can go write that code. Now, if I go try and run that on my web browser, you'll see nothing much is happening. The reason for that is because you can't think of the web page as the terminal, because if you press F12 or you right click and you click inspect and you go to the console tab, this is actually the terminal for a web browser. So when you console log something in a web browser, you're actually writing it to a terminal inside the web browser like that. Very interesting difference. Now, you can write normal JavaScript this way if you'd like to. Again, I can say for let I equals 0, I is less than 10, I plus plus, console log number is I. Easy done. Refresh the page, I get, for loops and stuff. So that part's okay, but there's a few things if I try and do it, it'll get confused. For instance, again, if I say import fs from fs, it's going to say to me, what is that? It's getting very confused there. There is no file system thing there. I can't say something like, here's another good example, process.argv, right? So if I, for instance, let me open up a terminal here. If I create a random file called test.js and I go console log process.argv, what you'll see here is that it prints out a bunch of stuff. If I do that here and I say process.argv on the web browser, it's going to say process is not defined. Similarly though, if I write something like window.height and I try and console log, I think it's window.height, JavaScript window height, inner height, or is it just height? Let's try that. Maybe it's angry about that. Let me see. Yeah, okay. Was height working? No. Okay. So I have this property called inner height, which tells me how tall the web browser is. If I reduce the size of the web browser, it's 574. This is how many pixels between the top and the bottom there. So that's really useful information. I can console log that on that magical window property. But similarly, if I open up this and I say console.log window.innerHeight and I run it with Node.js, no such luck. Window is not defined. So they're the specific parts of the runtime environment for those specific language, for those specific instantiations of JavaScript. Navigating around that can be a little bit difficult at the start, but again, at least you already know half of JavaScript. That's the main thing. So in terms of web JavaScript, and this will all kind of seem new, I'd say there are two main things that you generally use vanilla JavaScript for. The first one of those two things is the ability to, well, it's basically listening for the user to do stuff and actioning the change. So what I'm going to do is I'm going to get rid of that page for a moment, and we're just going to go back to basics for a sec. And I'm going to create a page here, and I'm going to create a header, and it's going to be called, mission control. And I'm going to call the page mission control too. So now we've got a very simple page. I might add some styles again. I don't love Times New Roman, so we'll get that out of the way. Mission control, sweet. There's my page, nice and simple. Now what I'd like to do is I would like to, on my page, create a account, right? The account's going to be 5. Cool. Now I want to create a line break, a void tag, and then I'm going to create a button that says I'm just going to have a plus in the button. And I'm going to have another button that says minus. Perfect. So I've got a plus and a minus. All right, now what I'd like to do is I would like to somehow listen to when those buttons are clicked. So what I'm going to do is I'm going to give both of those buttons an ID. One of the IDs is going to be called minus and the other is going to be called plus. Now we're going to have to do some JavaScript and understand a bit more about what's going on the page. There is a massive global variable in JavaScript called document, right? Document is gigantic. It is the whole page as well as a whole bunch of associated APIs and stuff. They're not really showing you the APIs, but it's basically everything. So if I was to say const page equals document, I'm literally getting the entire page as HTML. However, I don't want the whole page. I want a specific element on that page. And the way I get a specific element on my web page is I call a function on the document object called getElementById, and I give it I give it what I'm looking for. And now you'll see that if I just console log plus, I have found on my HTML page that particular button. So document's like basically a massive abstract model of the entire website. And I'm saying, no, I just want the plus button. But then what I can also do is I can say, you know what, for my plus button, I would like to listen for a particular event, which is a click event. And when someone clicks it, I want you to call a function. And I'm going to go write my function up here. I'll call it function fn. And all it's going to do is console log plus. So now when I click that button, it prints out to the terminal here. And that's because I've got a function called fn. I'm saying, hey, go get me the plus element on the web page. And then I want you to add something that listens to that plus element. Okay, cool. Sounds good. How you'll often see people writing this will typically, actually, I'll do that later. But now what I want to do, so I've got that kind of listing element here. Now what I want to do is I want to somehow increase this number. So if I want to change something on the web page, I generally need to wrap it in some kind of tag. One of the more generic tags is a span tag. It's essentially a propertyless tag for text, would be how I describe it. It doesn't have bold baked into it or italics or paragraph line breaks or anything like that. It's a really simple one. So what I like to do is when someone clicks on this, I would actually like to get the count. I've got to give it an ID too. Call it count. I'd actually like to go and get another element from my document, which will be called count. And I would like to, well, firstly, I'll just kind of print it out. Console log count, see what we get, just to make sure it's working. So I click the button, it prints out the HTML element. Now what I can do is if I want to, I can say inner text equals count.inner text, because every HTML tag will have the capacity to access the inner part of that HTML. Like, I need to console log that. We'll have the capacity to access that like this. And now I think, well, now that I've got that, what am I going to do? Well, I would really love to maybe make this a let and then say inner text plus equals 1. We got 51. Why did we get 51? Because basically everything in JavaScript by default is a string. So I need to somehow turn it into an integer. Okay, cool. So now when I add 1 to it, instead of it becoming 5, 1, the string, it's going to become 6, right? So now I've got my 6. And now what I want to do is I basically want to kind of go the other way around and say, you know what, count.innerText equals innerText, the variable. Maybe I'll rename this to be like new innerText or something, just so it's a little bit clearer. And you look at that. Now when I click the button, the function is called and the page updates. Now let's imagine I want to do the same thing for the minus. I'm going to rename this to be called plus. Maybe I'll call it plus function. I'm going to rename this one to be minus function. Okay, cool. So now I need to go and copy and paste this. Plus function, minus function, minus, like that. Oh, it's going up because I didn't do, minus equals. Here you go. So now it goes down and it goes up, and I've kind of controlled those two things. Then you think, what would be nice? Maybe cleaning up that code slightly, right? So we kind of talked about this earlier in the course. Is maybe I'll make a function called change function, right? You don't have to call it fn. And I'm going to copy and paste this. However, what I'm going to do is I'm just going to pass in a variable called change here, so that because it's the same code, right? And now all my plus function is going to do is it's just going to call change function with a 1 because I'm adding 1 to it. And my minus function is just going to call change function with a -1. Really simple. Okay, so they both still seem to work. And then you think, okay, well, here, I don't really need to, because this is, you probably have seen this from other parts of JavaScript, but there's a couple ways, like here I'm passing in a function, right? However, I can also do this. It's a little bit confusing. That is me passing in an anonymous function whose sole job it is to call a function. The reason I want to explore that is because here I don't want to call, I don't need this plus function. I can literally just call change function 1. But I can't do that because change function 1 will be evaluated to a result, which will be undefined because the function returns nothing. And then what it will try and do is it will try and add an event listener to the plus button that when it's clicked, you call the undefined function, which won't make any sense. So I basically need to wrap it in something that looks like this, right? That's what I'm doing. I'm saying, you know what? When I'm clicked, call this function. I'm creating a function on the spot, and the whole function's job is to call change function. However, you can simplify the look of that down to something like this. And I could do the same thing here for the minus as well. Say call -1. And now I've got a little compact piece of code that is kind of doing its job, increasing and decreasing the buttons. Now that's a lot of JavaScript, kind of plain old school JavaScript at its core. It's just a lot of manipulating stuff like that. Now, what I want to show you how to do is it's not just clicking. Sometimes it's key presses too. So let's imagine something I don't really do a lot, but let's imagine for a second that we're actually going to bind something to the body. So I'll actually give the ID. I'll give the body tag an ID. What I'm going to say is, you know what? Const body equals I mean, I could just use, document, but I'll keep it consistent so everyone's understanding. The whole page, the whole bloody page. What I'm going to say is, you know what? I want to add an event listener to you on key down. Okay. And I want to call a function, might be called like key down function. Okay, so there's a key down function. Now I go make a function here called key down function, and I'm simply going to console log key. I'm going to press keys on my keyboard. Okay, cool. So I'm registering that key anywhere on the page. However, whenever an event is triggered like this, whenever an add event listener calls a function, it actually passes it an event object. Now, we didn't care about this object. We didn't need it for the click, but let's have a look at it here. When I press a key, I get this object, and it's got a whole bunch of stuff in it. The thing I'm most interested in is going to be this key code here. HTML key code. Now, I want to figure out what the keys are for left, down, right, up. Left, down, right, up. Okay, I'm kind of following it. Left, up, right, down. Okay, left, up, right, down. 37, 38, 39, 40. Because now what I want to do is I'm going to make a little if statement here that says, you know what? If event.keycode equals 37, I'm just going to console log left, like that. Left. Oh, cool. And I hit right. Okay, didn't print out. Now, maybe I only want to do up and down. Now, up is 38. And down, if you remember from a few moments ago, event.keycode equals 40. That. Up, down, up, down, up, down, left, right, up, down, left, right. Okay, cool. That's working for me now. What I want to do now is I want to use this to change the numbers. So I'll just reuse the code I've written. When someone presses up, change it by 1, and when someone presses down, so now I'm going to go up, down, up, down. And then I think, you know what, let's expand this even more. Let's go crazy with it. And when someone clicks left, what I'm actually going to do when they click left is I'm going to jump by 5. And when they click right, I'm going to jump by 5 the other way. Right, so they click left, I've got to go -5. And when they click right, or on the keyboard, I'm going to go up 5. So up. I'm pressing up lots. Right. Left. Down. Right, so I basically created this dynamic thing here. We could enhance this a little bit more if we wanted to as well. Inside the change function, I could also say like, after that happens, if the new inner text, maybe I'll change that to be like new inner number, because it is a number, it's not text. If new inner number is greater than 100, what I would now like to do is say document.getElementById, body, right? I want to set a CSS attribute on the body. How do I do that? I can say body.style.background. So this is I think a really key part of it that we haven't covered, is that JavaScript allows you to manipulate the CSS of the DOM as well. And that's massive, because we can now style our pages where we say, you know what? We want the background to be red if it's greater than 100. And if it's not greater than 100, well, Maybe let's just make it none. So now what should happen is if I increase this, once we hit 100, the page goes red. And once I go below 100, because this is executing every time the change function is called. So that sounds really cool. And then you think, you know what? Let's make it even crazier. Let's actually say that what I want to do is not when it's greater than 100, but I'm going to say that, hey, the body's background, I want it to be RGB with 3 colors. Now you'll notice that I'm including this in a string, and that's because JavaScript doesn't understand CSS. It can find an HTML element and it can update a property of it, but it's just sending strings. And the CSS part of the web browser is the part that is processing those strings here, right? So that'll just make the page black whenever change function's called. If I press up, it makes the page black. What I want to do instead is say, you know what? RGB means red, green, blue. Let's make these all 250. Wait, how does this work? 255. That'll make it red. Okay. And this, yeah, you got to think about colors. And if I do that, it's white. Okay, so it's like, we always want it to be red, but what happens if it's 100? Because it's on a scale of 0 to 255, right? What is this going to get me? Okay, it's kind of. So what I can tell is I always want it to be super red, but these numbers here, the lower they are, the brighter the red it is. The higher they are, the more white it is. So now what I'm going to do is I'm going to think, let's see how tricky we are. I'm going to go replace these two with a variable called other color, right? And then what I'm going to do is I'm going to say, you know what? Other color is going to be a value where I want it to make sure it's always bigger than 0 and it's always less than 255. But otherwise, I'll just make it the new inner number, right? So when we start off on the page here, actually, yeah, then we need to kind of set the default. So I need to kind of do that here and say, you know, background, RGB, 255, 00. I might start the number off as 0. Nice and simple. Okay, so it's red. And now when I press up, what's happening is that it's actually adding that RGB value, I think. There we go. Yeah, see? Look at that. So now I'm kind of making the background a certain color based on the numbers. I'm just holding the key down here. So that's pretty cool, right? We're creating some interesting colors. I could do this with whole bunches of things if I really wanted to. We could have some fun with it. Let's go and have some more fun with the colors. Because I maybe want to get the header as well. I'll call this one like header. Or yeah, header's fine. And then here I will say, well, rather than getting the body, let's actually get the header. And we'll set its color to be the other way around, maybe. I want it, wait, no, so I want the color to be like white when the page first loads. Yeah, and then I want it to get more red. So I'm actually going to do the other way and say 255 minus this, right? It's a little bit mathsy. But it should be, yeah, I guess it has to start off as white. The header is white to start off. Okay. So now as I increase this, it should get more and more red. It didn't get more and more red. Ah, what have I done wrong? Oh, maybe the problem is, yeah, so I think this is probably a good example of like, think about what this string evaluates to, right? I think I know what the error is that when I put this here, you'll see that it's trying to pass this back, but CSS is like, I don't know what this is. It literally sees the dash and is like, that doesn't make sense. You're like, why is that not evaluating? Because I was just passing back a string. If I want to actually calculate that and return that to CSS, I kind of need to do it in the JavaScript part here. So now it's white and it should get more red. It's not, that wasn't the problem. But header, style, color, header. Interesting. RGB, that. Maybe I'll do background, see what it does. So a little bit of debugging here. I'm like, well, that seems to not be working. Maybe what I'll do is I'll just console log header, see what I get, right? And what I get is, yep, I get that particular thing there. And then I think, well, you know what? let's see if okay, so I want it to be that. Change the console log. Ah, thank you. I was hoping it was a more interesting problem than that. So glad someone's paying attention. All right, so yeah, it's white. Oh, background went to white. That's bad. I don't want the background to be white. I want the color to be white. So now this should get more and more red as the page turns like that. Cool. Right, now again, most people aren't going and building modern websites this primitively, you know? There's a lot of tools that we have that make it much quicker and easier. However, all those tools are built on the same fundamental thing. So a lot of you as students at the uni, you would have heard of Angular or React or this or that. All of those things are just languages that are built on this. They're all using what I've just shown you today, the fundamental principles at a scale that you couldn't imagine, right? So, and if you're learning some of this stuff, I would generally recommend always that you learn how to do stuff with the real tools. No terminal needed because the web browser compiles it all. And then what you can do is you can go and kind of graduate yourself into those other kinds of languages, because I've seen this a lot. Like, I honestly seen this from firsthand experience. If you work with abstract tools that rely pretty heavily on you needing to understand the fundamentals, you will struggle and you'll really hamper your growth. It's a very non-obvious thing though, right? Because you can think about it as a programmer. If you're learning C, sometimes it's worth understanding what's actually going on at the kind of under the hood level, right? The assembly level, just a little bit. Helps you understand, what's going on with a few things. If you're using Java, learning Java, you don't really need to understand assembly to make sense of Java, but knowing C really helps you understand Java and what's actually going on. With languages like React, which, it's really easy to be like, oh, it's a hot topic. React, React, right? It's like, sure, go play around with it. But the problem with React is, and I've employed people like this, I've talked to people like this, I've talked to Canva senior engineers who talk about it being a problem at Canva a few years ago, where like you get a bunch of people who they go and be like, oh, General Assembly, React. And they go do like a React development short course, and then they get hired and they do some React work, right? And they're great. They can make little pages and stuff. But once that things start to get complicated, that lack of fundamental knowledge really comes out and starts distinguishing people. So that'd be like, I think my probably summary comments on this is like, you can go and learn those other cool frameworks and go make something. That's really cute. I wouldn't say don't do it, but just make sure that that isn't the entirety of your knowledge. Because if that becomes the entirety of your knowledge, the second anything gets hairy, you just won't have the domain expertise to tweak it. And then also for the nerds out there, what I would really say to get you excited is that I don't have any hard anecdotal evidence on this one, but I'd be pretty sure that if you go look at some of the most performant pages out there, they've actually written a lot of stuff in plain old JavaScript because, like anything, abstractions slow things down. Just like we have lots of applications that are written in C as opposed to Java, because C is just faster because you're bypassing the abstractions and saying, give me the wheel, I'll look after it. It's the same thing with React and stuff. Like React is slower, but it makes programming way nicer and you can build more applications, which is great for like 95% of stuff. Like 95% of the time you're just trying to get good stuff out there really quickly. And then there's a small time where you're like, actually, we need something that's a little bit more boutique. I've kind of, again, normally there's more questions. We normally do this one in person and there's like a bunch of questions that come up. But are there any questions from the 12 people tuning in? Anything you want to chat about or ask about? Now's kind of the best time for it, because you've got me answering whatever you want. I'll just give you 30 seconds for the lag to catch up. Maybe whilst I'm seeing if anyone has any questions. Yeah, so it's like, what next? What next? If you're interested in this, you know, I can talk about studying another course and stuff, but if you're watching this lecture, there's a good chance that you have a personal interest in it. Go make stuff. Don't go and that's good. Positive comment in the chat. Don't go and just learn things. Don't go and study the HTML page. Go make something. Go make a game. You know, go make Space Invaders. Like what I've shown you today is enough to make Space Invaders. Because if you think about it, all Space Invaders is a bunch of blocks on the screen that move around, right? Now, just to maybe quickly touch on that, what I could show you about Space Invaders is I'm just gonna just quickly make a thing down here. A div is like a span. It's kind of an empty tag. I'm gonna put an emoji there, like a. Yeah, eyeballs. It's like a span, except that it takes up a whole new line, right? It always takes up a whole new line. What I'm going to do here is I'm going to add a style to this div. Now, you've seen a few HTML attributes. A style attribute, we've glossed over this, is actually where you can inject CSS straight into the element. You don't always need to separate it out like this. It is considered good practice though. So from a style perspective, what I'm actually going to do is I'm going to say, well, firstly, font size is going to be 4EM, make it massive. And I'm going to say width is 50 pixels, height is 50 pixels, and I want a black border like this. Okay. And maybe I'll make the background blue because so it's more distinguishable. I made that box not big enough for the size of the eyeballs. Yeah, I overdid that one again. There we go. Perfect. Now, just to give you another example, let's imagine for a second that I might put another button here. And it's going to be like a mystery button, little orb, right? And when someone clicks this button, right, mystery, what I'm going to do is I'm going to call a function. This time I'm just going to define it as an anonymous function like this. And what it's going to do is it's going to do a very similar thing to what we did with the count, how we increased it. However, margin top 0 pixels. Ooh, little orb button. It's pretty exciting. What I'm going to do now, though, is I'm going to say, you know what? I'm going to go and look up my, got to give it an ID. I'll call it my eyes box. And I'll say document.getElement by ID eyes. Okay. Yep. So I get my eyes, and then I'm going to console log eyes.style.margin top. You'll notice that unlike margin top with the dash, I have to use the kind of camel case here. That's because JavaScript doesn't understand property names with dashes. If it did, they'd just do that, but because it doesn't, they have to kind of modify it slightly. Now, when I click that, it says 0 pixels, perfect. So now what I want to do is I kind of want to increase that. How am I going to do that? I'll say new pixels equals this dot replace pixels with nothing, because you can see pixels as part of the string there. And then I'm going to want to turn it into an int. And then I'm going to want to add 20 to it. And then I'm going to say eyes dot style dot margin top equals, what am I going to say here? New pixels pixel. So I'm basically like changing the margin at the top of it. Whee, look at it go, disappearing into the distance. You think, well, that's cool. I could do the exact same thing if I wanted to with the change function, right? In fact, screw it. I'm going to change how all this works, where instead of changing the number on the key downs, I'm just going to make this thing move just because I can. I'm going to get rid of the click. I'm going to get rid of the, I'm going to get rid of the mystery button. So I will come down here. I will now create a new function called move eyes, and I'll give it a change, just like everything else has been doing. And it will very simply, and then I kind of need a direction. How do I do this? I'll say up. Up equals true. So I always want it to go up by default. And I think, oh no, okay, this is going to be complicated because I need to kind of move in different directions. Ooh, all right. Well, I probably need some if statements here now, where I'll have to say like, maybe I clean this up a little bit. I'm just powering through this now because I don't need to kind of drag it on forever. But I'll say like maybe I'll say like, I'll let property be null, and then I'll say, you know what, if up and change, how does it work? Up, left. I guess I could just do a direction. You could probably use an enum here, but I'm just gonna, it's not very clean of me, but I'll basically just say, you know, direction is either left or right or up or down. Yeah, all right. So if direction is up, well, the property we're looking for is going to be eyes.style.margin top. I guess, or if it's down. So I'm kind of figuring this out as I go with you here, right? So basically, if it's up or down, I want to play with the top margin. Makes sense. Else, if direction is left or direction is right, then I kind of want the property to be the left margin, I guess you could say. Oh, that's why I was, sorry. That's why I was doing this before, I think. Because I was kind of like, I think that's where my brain was going at. Was basically saying, you know what, if it's up, then we're going to be changing the top margin. And if it's not up, it's just an else statement. If it's not up, then we're going to do that. Right? And in fact, I could make this code a lot cleaner if I wanted to and just say, you know what, if it's up, then it's that. If it's not up, then it's margin left. Make my life way easier. Because now what I want to say is basically go get the property I'm looking to change and then go set that property. I've never quite done that where I try and set a property like this. We'll try it out. Let's just imagine we're always moving it up for now. We'll go and tweak this later. So any key should move it. Yeah, I don't think that's working. We can double check. Console log new pixels. Key 0. Okay, I'm always getting 0. So that doesn't really make sense though. All right, well, now let's console log property. See what we get. Oh, no, that's good. Sorry, we should be getting 0 pixels. That's what I want to see. Let me just make sure that, yeah, okay. 0 pixels, we parse it. New pixels should be 0. I'm not thinking very clearly, am I? Let new pixels plus equals 20. We'll print out what it's like after that, but I think this property one isn't working. I think that's just not how programming works. I'll probably just have to do a similar thing here where I say like, you know what, if up, then it's just margin top, you know, equals this. Just don't think that's how programming behaves. And if it's not up, then it's margin left is that. Okay, so that seems to work, but all my keys are moving it down right now, which I don't want, right? What I want it to do is say, you know what, when you go up, make it negative 20 pixels. When you go down, make it, because, you know, down is adding more margin. When I go left, I want you to add more margin to the left. Okay, positive's good. And when I go right, add stuff there. And then I think, you know what, I'm probably going to need a way to, well, yeah, now I need to make this instead of 20. It needs to be changed. And then I'll probably say, you know, new pixels equals math.max 0 and new pixels. Just to make sure that it doesn't drop below 0. See if this works. Oh, it's not moving sideways. I'm pressing up and down and it works. And I'm pressing left and right and it goes up and down. Why is that? Probably because these two here aren't set to false. Okay. So when I press left, so left and right, nothing's happening now. So then I think, okay, let's try it out. What is, I think I know why, but let's print out new pixels, left, 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 not a number. Okay, that's interesting. Let's have a look at this. Not a number. All right, let's really get to the bottom of it. The reason, and this is a very subtle, annoying thing about it, is that whilst it has a calculated margin left, I didn't explicitly set one. So when I ask JavaScript to give me the margin left of it, it doesn't come back with 0. It doesn't come back with what it calculates, because obviously there's lots of stuff it needs to just calculate. It comes back with, I don't know, because it's blank. So that's why I set the margin top as 0 before. Okay, so down, down, up, up, left, left. Left went the wrong way. All right, got that wrong. Yeah, because left should reduce margin. Sorry, that makes sense. Whee, look at that. Cool. So now I've made this little thing move around the page, and this is kind of my point. You can play space, you can make Space Invaders. Go make it. Go do that in your spare time. Uni's a great time. You'll do a bunch of work for free and you won't even punish yourself. Speaking of that, I tell people this all the time. I don't know what happened, but around, and this happened to a lot of my friends, around the age of 25-ish, we just stopped wanting to do dumb stuff for free. You know, like, I think it's because it's not true for everyone by any stretch, but I think at least half the people is like, you kind of get to your mid to late 20s and then, or maybe mid 20s, somewhere 23 to 27 is a pretty typical age range. And you suddenly realize that like, hey, I need to buy a home one day. I need to do a lot of stuff and I probably can't just like be young and not have any money. So then suddenly when someone's like, let's work on a Space Invaders game, or we'll put it on the App Store, you're like, is that going to make us money? And your brain starts to go, maybe not, maybe it's not worth my time. So uni's an exceptional period. Go do all the things that don't make you any money, because it is just this magical period where your brain is just culturally hardwired to not care about that, you know? So go make your Space Invaders game. Go make any game you want. It's all very primitive tools. But my point is, back to the start, because this was a very long tangent from the question of what next. Go make something. Don't learn about it. Don't learn about it academically. You will learn everything you need to know trying to do something. Even I wouldn't say I specifically learned a ton there, but because I've probably done these kinds of examples before, but I had to figure things out, right? Being forced to figure it out, like making something is a form of forced learning. So go do that. Go make a game. Go make an app. I think one of the earliest apps I ever remember making was this little thing where it just prompted like times tables, 22 times 12. Type in the number, hit enter, give me the next number, hit enter, give me a score at the end, tell me how long it took. You know, probably the only essential thing that I haven't shown you here would be set timeout and set interval. They're both pretty important functions in general with JavaScript. That's basically how you do something at a point in time. Like let's say you're making Space Invaders, you kind of want the little Space Invaders things to go doot, 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 doot. You want that to happen every second. Set interval is a function that allows you to call a function every 1 second and cause a change to happen. Alimul says, how do you do front end with other languages? Does script only work for JavaScript? Yes, this is why JavaScript's become so popular. It's a pretty ugly language. It's okay, like it's not the worst. People like to make it out as pretty bad, but it's definitely got some problems. It's not quite Python, but it is the only programming language that web browsers understand, which is very interesting. That's why Node.js was invented. It's the other way around, right? Like some of you might think Node.js was kind of new, but Node.js was invented because people were noticing that everything was being built on the internet, on web browsers. And then they were like, man, if all of these companies, Canva, Google, Dropbox, Meta, are just making JavaScript everywhere, and everyone has to learn JavaScript, why don't we just make JavaScript a server-side language too? And then we can just embrace JavaScript and everyone can just understand one thing. And there's some major practical benefits to that too. Like in a lot of code bases, you can actually write config files that can be imported by both front-end and back-end code, which is wonderful. The real question is that going to be like that forever? It's probably going to be like that for quite a while. I don't know exactly how long, but I bet 10 years. Where things get really interesting is in the world of WebAssembly. So WebAssembly is it's called WASM sometimes. It's I don't know how to write it in WebAssembly editor, Explorer. Maybe that's what I want. Yeah, I don't really know what I'm doing. So basically, yeah, okay. So WebAssembly example. I'm not trying to go deep into this, but over the last years, what has started happening is that browsers they've been building into browsers the support of something called WebAssembly. So that's Java C on the left, right? And what WebAssembly is this basically an like a bytecode-esque thing that browsers can understand, right? So you kind of get like Java compiles to bytecode, Python compiles to bytecode, I think. And what that means is that there's like a really primitive base language that browsers can understand that isn't JavaScript, which is WebAssembly or WASM. Now, why is that interesting? Well, a couple of things was that, in theory, it was meant to mean that people could write really high performance applications by bypassing even some of JavaScript's abstractions and instead like writing directly to, normal assembly, right? Like a lot of you have had to learn a little bit of assembly with 1521 if you're an undergrad. I'm not sure what postgrads do. But the point is, what this is going to do that's so interesting is it will eventually usher in a new generation of programming for the web, because browsers will understand JavaScript and they'll understand WebAssembly. However, you can theoretically compile any language into WebAssembly. That's what this page was before. I've never really used it, so I don't really know how to use it. I'll probably just screw it up. But the point is that you will eventually, let's just write a main function. I don't know what I'm doing. Never seen this website before. Let's try it out. Looks like C++ is getting compiled into another language called WAT or what? Never heard of it. Which looks like it then will assemble into but the details don't matter because there's going to be a million different ways people do this. But the point is the fact that you can reduce your code into a common language that browsers can understand. Because in theory, you could write something in C++ or Python now that outputs JavaScript. You know what I mean? Like you could write a Python front end and it compiles it to JavaScript, but that's so difficult to get that kind of parity because JavaScript's a really weird language, whereas when you get a base language, it's really great. I mean, it's nothing new in computing. They've been doing it with other things for a while. Is Rust a WebAssembly? Is WASM? I mean, WASM stands for WebAssembly, I believe. I don't know what this page is about. I'm not going to play around with it. But yeah, eventually there'd be things like Rust being able to, compile into the browser. I don't think that's so much going to be like, oh my God, front ends are going to be super performant, because most front ends don't need to be that performant, really. Like, I mean, go look at Google Chrome. Your Google Chrome is going to be using like so much memory. Like even just this page here, it's 151 megabytes of RAM. Let's look at our stupid page. How much RAM is it using? 37 megabytes for this crap. Like there's nothing here. So web browsers are clunky and slow, and I don't think that's going to be a massive problem. On mobile, that matters more. I think probably the more interesting thing will be you'll see a bunch of people who are building high performance applications in Rust who maybe don't want to go and use a separate programming language to make a front end. But I just can't stress to you enough. It is so slow for things to happen. Like don't sit around being like, oh, it's going to take over this, it's going to take over that. It's like declarative frameworks have largely solved a significant amount of problems with JavaScript in general. So if someone says to you, oh, well, Rust is better than JavaScript, it's like, sure, but no one's writing websites in JavaScript. You should learn how to so you understand the fundamentals. But most people are writing websites in React. And if you think about it, React actually did the thing I mentioned before. They literally wrote a language that compiles into JavaScript. It's just easy because React itself is JavaScript based. So they don't have to figure out how to like take another language like Java, which has types, and like unfurl that into something else. So React kind of didn't do the WebAssembly thing, it did the JavaScript thing. We call that transpilation because React is JavaScript and it compiles or transpiles technically into JavaScript, right? So if you're compiling JavaScript into JavaScript, we call it transpilation, not compilation. WASM is a result of compiling Rust or other languages. WASM is pretty much the only language you can run aside from JavaScript. Yeah, okay, so I didn't realize WASM is the direct result of compiling Rust. I guess that makes sense because you've got lots of languages that will use a Rust compiler. Or other languages, yeah. Sorry, no, I misunderstood you, Thomas. Yeah, so WebAssembly, pretty cool. You can go and play out with it. I was like, how to write WebAssembly in Chrome. I'm sure there's an editor or something. I just haven't tried. Using a WebAssembly Chrome extension. You can probably go make a web page yourself. Sorry, you probably couldn't make a web page because WebAssembly is assembly. You would be writing a lot of code and having a lot of painful hours just to get something basic to work. But it's pretty cool. Keep an eye on that. But again, you're not going to see anything transformational in the coming years. But it will be kind of where more things end up in the future, and it'll definitely democratize what happens with front ends eventually. I think that's all I really have time for today. Well, it's not all I have time for. We got time, but I've gone deeper on stuff, and no one's really asking any more questions. So let's wrap it up there. Thank you to the 12, 8, 14 people, depending on what time that joined in today. For anyone listening now or later, it was lovely. So I got a question. Damn it, wrong timing. Bad timing. Is there a way to change the color gradients in a non-uniform manner? Yes, there is. It is called linear gradient. It's a way to wrap a CSS value. So instead of using a color, you can say I want a gradient between a couple of things, and you get beautiful, lovely gradients. You can also animate them too, which is pretty cool. CSS gradient animated. So you can combine CSS animations with gradiented backgrounds, and you can produce stuff like this. Look at that. Whoa, lava lamp. Pretty cool. Anyway, sounds good. I was just saying, it's been a pleasure talking to you all this term. I know I haven't had a chance to meet most of you because you don't turn up in lectures, which is fine. I wouldn't either. But regardless, add me on LinkedIn. Hope we can stay in touch. I'll see you around uni at some point, or just generally in the future. And thanks for your time and patience. It's a lot of listening to me talk in your ear. So